We're very happy to be here, Sina and I, and also some other people from our team, Signals. Maybe just as an add-on, this is where we are situated. We are directly on the campus, the life science campus of the Frankfurt University. And that's where we have our office and also our main first user base. So there's a lot of interaction with the scientists. All of us have a scientific background, mostly from life sciences and structural biology. And we have now kind of switched, and we are now doing the coding and the programming of this electronic lab notebook. When we say logs, we've branched out a little bit. It's a bit more than just one platform. It actually consists of a multiple approach. We do have the ELN. We also have a scientific data management system, SDMS, and we've gotten a Python logs API, which Sina will say more about shortly. Logs itself basically enables scientists to save their data in a central hub. This hub can be on site, which means you can install it on hardware in your lab or in your institute. You can also do so on virtual machines, or we can have it saved for you online and deliver it as a software as a service. The data is basically uploaded automatically or by hand from the lab. And this greatly simplifies, I think, the data and the primary data pickup. So today we'll talk about the data gathering from two sides, one through the ELN, right here with the electronic lab notebook. There's not much to explain here. I think it's almost intuitive. Everybody's used a notebook by hand. I have certainly, and this electronic lab notebook is supposed to replace this with some, with some advantages. For instance, automatically linking maybe to other data, or automatically allowing you to place template text into the notebook and keeping it ready for posterity. Besides the ELN, I mentioned the SDMS, the Scientific Data Management System. The SDMS sits on the same server as your ELN and is delivered by the same server. And what it does basically is it gathers data from the instruments in your lab. So at the left-hand side, we have schematically these instruments. On each of these, you will have a client software installed, very small client software. This client software can be told, to automatically upload, for instance, in 2-minute intervals from this instrument, looking for this data method and this data format. And right here is also already the first instance that you can see that metadata is already entered with the data, with the measurement data in the system, right? Right here, you already can see, it's an EPR spectrum, maybe even the data format. And here we have a directory that's being searched, and more often than not, scientists, of course, have more information in the directories, the name of the person, maybe, or the name of the project, or the name of the sample. And you can configure this client or logs. You can configure logs to automatically search and recognize data and already link it to the measured data right here at the beginning, right? So with the birth of the data, if you will, we've already striven to connect the metadata, which later on becomes so important. There's more things you can configure. Here's the data source. This is something we save as well. So from which host did it come? Where was the data acquired from and picked up from? Again, this is maybe not so interesting for the scientist, for his scientific results. But if you want to be fair, or if you want to make sure that you know where your data is coming from, this is the first place that we turn to. Once data is uploaded and the person logs into logs in his web browser, this would be what he sees ideally, right? Or one view anyhow. Up here we have the navigation bar, projects, samples, dataset, documents, etc. And if you click on datasets, you have this table. I'm now going to open up a demo. So here are the datasets that might have been collected by the whole group. We have text search functions. Looking for the protein ubiquitin, for instance. We can then make sure that we only see NMR spectra. And let's make sure that we only see those data sets that are, in this case, let's see, part of the LOGS demo project, which I, of course, prepared earlier on. And so I found these two ubiquitin measurements, NMR, done on this protein. There's more information about the sample here on which instrument and when was it acquired. I can also click on this, and I can now see the what we call the detail page of this data set. You see the data set details, in this case with the NMR pulse sequence, 1D1, so it's a 1D proton spectrum. What project this is part of. Here is the sample. We can also jump to it and see a similar page for the sample with more information about this. Here's the source information. And here is a little tidbit which I'm happy to show you already. Here we have listed all the entries in the ELN that this sample is mentioned, that this data set is mentioned in. So I can click on this demo lab book, and here you see the first preview. Here's some text, etc. I'm not in edit mode, but here's the spectrum that we just had a look at. So the point is that with each spectrum, with each data set that you find, LOGS automatically links any ELN entries that might have been carried out. Yeah, so allowing you to go full circle. Okay, I am going back to my talk. So this page I keep ready in case the online demo doesn't work. We can do what I've just shown for many data formats, currently about 70 data formats. This is, of course, spread out on various methods, right? I know there are about 4 or 5 NMR methods or NMR formats officially that I know of, at least, Bruker, Agilent, 3 others that I've forgotten now. And we speak them, but of course we also are very eager to add more formats. You name it, UV-Vis, fluorescence, CD, anything at all that you use to maybe create your samples or check your samples. And once these formats are implemented in LOGS, then we can carry out what I've just shown you. LOGS is able to recognize these formats on the instrument. It's able to recognize whether it's just been acquired. The file content will be parsed and the metadata extracted. We also extract the measured values and then display them in the spectrum viewer, which I just forgot to show you. Anyhow, what's also quite important is that, of course, there's always some tailored functionality depending on the measuring method, right? So for instance, with NMR, you have the time domain for induction decay, and this you want to fast Fourier transform and show, and we do that. So where necessary, we are able to take the data, maybe process it, and then show this in the viewer to the scientist. Okay, so summing that up a little bit, we've got the scientific data management system. Yeah, we gather it up, we hoover it up, if you will, and we keep it ready for scientists, maybe for other research groups, etc. So that's for the people. But I think what's really important is that we make data available to other software platforms as well, right? And that could be for LIMS or other ELNs. And of course, we are always going to throw our hat in the ring for this. We have an ELN as well. But I mean, ELAB FTW is, of course, well known to the NFDI people. There are other ELNs that we are already able to transmit information to. One of them is LabStep. For ELAB FTV, I had a meeting with Nicolas Carpi very recently, and we both talked to each other, and maybe we'll start a little collaboration. We have to see, it's still in the beginning stages. And I think this is very important because, I mean, the scientific data management system is there to gather the data from the instruments. And this, I think, can, if it's digital, we can gather it and we can work with it and we can make it findable. But for the researcher in the lab, the research is different. So either you're a synthetic chemist or you're a structural biologist or something else, and the ELAB that you will be using needs to be tailored to what you do, right? So one ELN is not going to cover all the research functionalities that would be necessary, but what we are eager to do is, help all the ELNs that exist, of course, including ourselves, with the SDMS and hold the data ready. Yeah, so maybe keep that in mind. Okay, more specifically to our ELN now, and then after me there's Sina with the API. He's got some nice examples to show. So our ELN is very young. As a matter of fact, it's so young that it's not even on our website yet. Maybe you'll have noticed that, but that will change soon. Yeah. The ELN is already being used by the first users, especially on the campus that I showed you in Frankfurt. And we are happy to have the necessary basic functionalities. We still have a long roadmap ahead of us, but we think it's very eminently very usable. I'll show you why in a moment. You know, the ELN is a hierarchy. It's a notebook. Every notebook has experiments. There are gated entries. The header is the table of contents is header oriented. And what our standout functionalities are, I've tried to list here. There are probably more, but these are the ones that come to mind immediately. The fact is that here's a screenshot of the ELN, which I'll go into more detail in a moment. Typically, this kind of reminds you of Word, if you will. You know, you have the typical text editor with all the necessary bells and whistles, text headings, tables, I don't know, Greek letters, whatever you want. But I think what differentiates us from maybe the others is the fact that on the left-hand side, the SDMS delivers the content that it has gathered in the lab. And this was done automatically, but I want to interject that even if the data set isn't in there yet, you can always take it, you know, maybe from the browser in on your laptop or your PC, and you can drag and drop the data into this window, and Logs will recognize it and also upload it and then put it into the SDMS and keep it ready with the same functionality and the same advantages. Okay, so here we have Logs content. In this case, we have data sets which are in Logs. You can filter them, and then you can actually pick it up and drag it into the ELN. And I have another demo, which I am going to open here. So currently, this is what our dashboard looks like. If we have the ELN functionality activated, on the right-hand side, we have all the content that was gathered by the SDMS. We have the, you know, in this case, just a small subset of samples, data sets. It's only a demo after all. And on the left-hand side, we would have a list of the notebooks that this user might have. Here we have only one, the demo notebook. These are the experiments that are listed in this demo notebook, and these are the entries ordered by date. I can click on the notebook. I arrive at the page that you just saw the screenshot. And here we see the table of contents. So it's by notebook, it's by experiment. Here are the entries. I can jump right to this entry right here. And just looking at it from the bird's eye perspective, well, you know, I think it's quite intuitive. If I do want to continue editing, I can do so. And if I want to add content, editing, I think is clear, you know, just a simple editor. And this is what I meant earlier on. If you want to add content, well, you can look for data sets or documents, maybe templates if you want. Here are some templates that we have. I basically copied these from users on the Riedberg. I'm not even quite sure what they all do, to be honest. It's maybe not so professional for this, you know, giving a demonstration with templates you don't know. But the point is, I can click on it, and then this text is entered, right? If I want to add other types of content, I could say, okay, let's have a look at the data sets. Yep. In this case, if I want to make sure that I enter the correct data set, I could click on it and just have a quick peek. This is a gel, actually. All right, so why not? You know, gels are important. I've never done one in my life, but okay, as a physicist. But so here's a gel, and I've basically entered it, and I could then continue writing. And the beauty here is that you could, for instance, export this as a PDF and keep the link, perceivably. And if you give this PDF to somebody, then they could click on the link, and of course they have to have the login details, etc. But they could click the link and arrive at this page or at the detailed view of this data set. Yeah. So right here we've got this circle, right? Someone can be given a link to this ELN, or someone can be given access to this ELN, and this person could then you know, come to this ELN and basically have a look at the data itself, or in Logs just quickly check with the data set. And because the data was uploaded, you can also download the data, the primary data, or maybe even more information, and then really quickly jump from the manuscript to the actual data in question, right? So we've linked that up. We're quite happy with it. Okay, so that was the SDMS. That was the ELN. I'll let Sina join in a moment, just to sum it up a little bit. At the end of the day, what we want to be, and in part R, is a communication platform. We want to, transfer the data from the instruments and then get the data from the human instruments as well, with the documentation, with the ELN. And then, of course, we want to be able to communicate this data to other platforms, be it Zenodo or Figshare, maybe even the Chemotion, repository. I've already asked Nicole Jung about the API. If possible, we want to we want to connect the scientists with the necessary platforms, starting with their platform, with their machines, with their instruments, and then even enable them to do their ELN entries and maybe link that or not. And then I think we've come much further than we were maybe 10 years ago when we had this idea about logs. Okay, another very important deal for this is not just the entry via the ELN or automated from the instruments, but allowing people to maybe download the data using kind of scripts. Python is of course very popular in the community. Do something with it, and then maybe record that with logs as well. But I'll let Sina talk about this. This is something that he has headed up as the project leader.
So far we talked about, or Jakob talked about, a lot of the interaction you have with the software to get data in and curate the data, organize the data that is using the graphical user interface. I want to show you some power you get when you use programmatic interfaces. So you access the data and your structures with the program, with the code. To provide this, to allow you using scripts and programs to access data from a web application, you normally implement a RESTful API that we implemented also in logs. And this will allow you to access all the contents, all the information you have in your logs server. So this means that you have access to all the data sets that you recorded, you put in different ways. You can get the original files that were uploaded. You can also extract parameters that we extract from the original files and the tracks. So basically all the information that you saw before on this detail page, you can also extract using scripts. And in addition to that, you get also all the metadata and relations. So the project organization, the samples, and all other things. And you can use this programmatic interface to connect logs with third-party software, for example, analysis tools that you are used to in your lab. And you can do, if you want, extensive data mining, of course, because you have all the data in a structured manner in logs. And you have also additional information, metadata, that you can extract and use data mining if you have a lot of data and you want to understand properties of the whole thing. And as you might know, if you worked on data mining projects before, it is really necessary or really useful to have metadata and structured information. Then the better your data is organized, the better data mining you can do. And later I will also show you an example how you can use this programming interface to communicate between logs instances. For example, if you move from one lab to another that has another logs instance, so you can take your data with you, the information with you, or if you're in cooperation with another group or another working environment that is using a different logs instance. Of course, scientists are concerned with science, so they don't want to bother using web technology or learn it, or just don't want to bother with it. And for that, we are also providing a Python library that is the connection between logs and Python code. With that, you're able to use logs with a native Python object system. So it means that you don't need to think about the communication between logs and your script and so on. You just work with Python as you are used to. You have just objects you work with, and the communication is done by this library. So this logs Python library will also allow you to integrate your logs system to other tools, because many tools are either even written in Python or have a Python interface, which is quite common these days as Python becomes more and more a standard language for data mining, data analysis, but also for scientists in general. And you have also in Python a vast number of available libraries that allow you to do this kind of analysis, which I will also show you in an example. And you can customize and automate all the processes that you have in your lab daily. For example, imagine that you do a measurement, logs gets this data from the measurement, you have a script running after that automatically that analyzes this measurement, puts the analysis on the server, back to the server, so you have automatically analyzed your data, and you can also create, for example, reports, statistical analysis on the measurements that you did before. And this will allow you to, for example, hand over this report to a user that is not expert in this specific measuring methods. Integration of third-party systems is also easy because they use Python a lot. Also, other tools use it, and you can also use Python analysis for data mining and AI if you want. I know not all of you are familiar with Python coding or are coders of Python, so please bear with me. I'm daring now to show also code in such a talk, but I think you will also see that using this interface to interact with your data is quite easy, even if you are not much familiar with programming here. I want to show you this code here. This is just an example how you would connect with logs. You import this logs object here, and you need an API key. This is a key that you generate inside the logs UI and use for authentication, because you don't want to put your password in all your scripts. And then you have just a URL that tells this library where your logs is, which instance you are using now. So you create this logs object with this URL and then API. And after that, this logs object is your interface between logs and your Python code. For example, you can get the dataset by just putting here logs.dataset and then the ID of the dataset, and you get an object that has all the information of this specific dataset. For example, I print out here the name of the dataset. This was from a honey study, and also the experiment. This is an NMR dataset, so I have the experiment and I just print the name out here. So quite simple to access datasets with this logs Python. You can also get a lot of datasets, or all your datasets even, by using a simple for loop. So again, here you have for dataset in logs.datasets, and with this for loop, you could get all your datasets one after each other from the server without bothering with the download and so on. This is done by the library automatically, and you can also filter it. So I just for the case for this example, I use the filter where I only get the experiments that are HSQC. This is an experiment of NMR, and also all datasets starting from the 1st of 2022. So you can have all kinds of filters. You saw on the detail page or the dataset page before, all the filters on the site. You can also use all this kind of filters and actually even more in the API case. So you can go over all datasets starting from the 1st of 2024 that are with this experiment and list them with this small script here. Okay. So one example that we are, or one case that we are asked for a lot by our customers for different reasons is to download a set or a subset of the datasets to the drive. So, for example, some users have analysis tools that work on a lot of datasets, and they want to download that, like a set of them and use this analysis tool to process them. Another case that we recently have, a user wanted to move away from the lab and wanted to take his own data sets, the data set he measured over the years, with him to the new lab that he is moving to. And I just wanted to show you how easy this can be done with Python script, you just basically, you extract the person with the username of the person, then you have this user. Then again, you create a for loop of the data sets that has this user as an operator. And once you have this for loop, you can just use the object from the for loop with this download function. And then you get the downloaded zip file to this directory that you wanted, your target directory, and extract all the zip files there. And with this small script, you can extract all your data set, and with the filters that you can establish here, you can have all sets or subsets of data sets or other entities from logs that you want, just easily with a small number of code. The other example I want to show you here is the communication between two logs instances. So in this case, we want to communicate or move some data sets from one logs to another system, or the samples from one logs system to another system. For that, we generate just two logs instances. One is from the source URL, the other one is from the target URL. So we have two logs instances, and then we extract, for example, all samples for a specific person. I just put myself in there, so I extract all my samples. Again, I have just the for loop, samples in source logs, samples, and the owner is me, the user ID of me. And after that, I have the sample objects that I just create in the target logs. So I just communicate this by moving this, creating this sample object in the target log system. And because this sample object has already all the information extracted automatically, I can move the sample object to the new target system. What I also can do in between is renaming this samples. What I do here, I add an underscore copy to the samples, and with that I can always recognize the data sets that are transferred to the target logs from the source logs by the name, because the name has an underscore copy there. So, for example, communicating between two logs is also quite simple. So now I want to show you some a bit more advanced examples that we implemented with this logs Python library that are more focused on the content. So I more or less leave the code now. One example that we looked at was for a customer that wanted to see how the instruments are deployed in their system. So they use logs for a couple of years, and they have some instruments, and they wanted to see how these instruments were used over the years and how they are deployed there. So what we did, we extracted the data sets for each machine and separate, and counted the number of measurements that were done for each year of this instrument. And you can see on this left side that the instruments were used differently in the different years, and also not all instruments were used in the same way. However, this is just a number of instruments and not really the instrumentation or the deployment of the instruments. So we also extracted another feature from logs, so acquisition parameter that is the duration of the experiment. So let's say how effectively the machine was used really, or occupied by measurement. And if you plot this, so the usage of each machine over the years, you can see a different picture. Some of the instruments were used basically all the time. The reason for that is that they use a lot of automation there on this instruments, and some others have a lot of measurements done on them, but the measurements were quite short, and they have, let's say, some sleep or standby mode, a lot of standby mode over the years. So with this kind of statistics, which is quite simple, actually the customer is doing much more complicated stuff with this. With this kind of analysis, you can understand how effectively your instruments are used, how your instrumentation is used by your group members, and identify bottlenecks on your instrumentation, and maybe use the instruments in a different way. Another possibility you have here is if you are a core facility or in general do measurements for others or for customers, which is maybe not so often done in science, you can use this information that logs has to create bills or invoices for your different customers. I want to show you a script that we used here to do this kind of invoices or billing. I don't want to go into details. I just show you the script to show you again which features can be used here. So I go over all persons that are in this logs instance. And for all persons, I collect the data sets and accumulate the duration that was measured here. And with that, I can basically create the cost of each data set, or the cost of measurements that were done by this user. I can also extract some other information here to make the invoice more correct here and collect, for example, the sample here. So after running this script, you get for each user the number of data sets they were measured, the number of samples they were using, and specifically the measurement time. And with the measurement time and some kind of factor here, this is quite simplified. It's actually more complicated how they build their customers. With this factor here, you can calculate how much cost this specific user generated in the lab. You can do it also for other users. So you have all the information to create an invoice, but we can actually go a bit further. We can make a step more, because Python has a lot of libraries to generate content or styled content here. I know this is not very nice, but I'm a developer, not a designer. So it's just like a simple design to show you the capability. You could obviously design this much better. But as you see here, the script can automatically generate even the invoice. So you don't have to go into, let's say, Word and type in all the data and create an invoice. The script can automatically create reports, or in this case, invoices, number them, put the user information here. You could also put more users. It can explicitly tell the user which samples they use to measure, how many, and also the cost of these measurements. And this is done for all users that are in this lab. Another case we have here as an example is the connection between logs and other third-party systems. For example, this specific customer has another ELN that is deployed there. It's called LabStep. And in this ELN, they wanted to put some data that is available in their logs system. So they use logs and LabStep ELN. And logs has their data sets acquired automatically. So it uses the client to get all the data set and extracts information from the data sets, like the plot that you can see here, but also acquisition parameters from the data set data. And they have naming conventions so they can recognize their data sets here. So what the user wants to do is, in the ELN LabStep, this is a screenshot of the ELN LabStep actually, they want to create tables that show the data sets and some properties of the data set, some of the acquisition parameters of the data set. They want to report them always when they do measurements. And what we created is a script that fills out this table. So the users just create a table within their ELN. They mark this table for the script by putting this hashtag here. And then they just fill in the experiments they want to be reported and the columns they want. So the properties they want to be reported. And this table is left empty by the customer, and a script in the back will fill out all this information. This system is actually in production and used by this customer. And we also put an additional column here where you can have the logs link put there automatically, so you can use this link to jump back to the full detail and see all the information here. And with that, I hope I could show you that using Python or scripting in combination with logs gives you much more power in automation and analysis, and you can basically make your life in lab, your daily life, much easier using this kind of things. And I want to thank you for your attention.